Hello everyone, this is the video lecture for Calculus 3, section 15.3, polar double integrals. So we've been learning about double integrals already with the past two sections. We're now going to be using the same kind of double integrals, everything that you've seen already, but I'm going to try to force polar equations into them. So in a way, and this is the big formula. If you're going to write something down, this is the big formula here. Basically, double integral of f dA is now equal to double integral of f r dr d theta. So when I say dA, I meant like dy dx, typically, you know, that kind of stuff. But I mean, it could literally be the same thing here. Notice that it's not just dr d theta. There's a requisite r. Ooh, I wanted to do a Q there. Requisite. I think I spelled it right, but you can't tell. Requisite r. You have to have it in there. If you don't have an r, an additional r tossed in there, whole thing's wrong. So I know that here it's kind of silly to like, well, we don't have anything extra. Now we all of a sudden we have to have a, you know, a times an additional extra variable. Yeah, it's important though, okay? So, let me give you some formulas that are hopefully familiar to you. X squared plus y squared equals r squared. Tangent of theta is equal to y over x. Also, x is equal to r cosine theta. And y is equal to r sine theta. So these are the basic polar equations that, you know, formulas we've been doing a lot since pre-cal. We're doing them again here. So all of these are used to make this go to that, or this go to that. Okay, so here we go. 15.3.009. So I got double integral over a domain of x squared y dA. And they give me some words with this, and that's why it's kind of strange here. They say the top half of a disk, okay, the center is at the origin, and then my radius is equal to 4. What are they trying to say? Well, they got a disk, radius of 4, and they want the top, centered at the origin, and they want the top half of it. And by top half, I'm assuming that they mean XY top half right here. So keep that in mind. It's a little weird because we're talking 3 dimensions sometimes. What do you mean by top half? Well, they just mean that part in 2D, I'm sure. Anyways, and I did that and it worked. So this is my region. I am now going to force this into this problem here. Notice that basically here I got blah 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 dy dx, right? Well, I'm gonna basically rewrite this as blah 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 something else r dr d theta. Oops. So that's my goal. I need to replace all this stuff. So here we go. I'm not going to concern myself with the region right yet, but I know that x is equal to r cosine theta. Square that. I know my y is r sine theta, and I must have a requisite r dr d theta. I'm going to now get all of my region stuff here, and this is where it kind of gets interesting. I'm looking for this top half, and my radius, to fill in all that, I'm going from 0 out until the 4. My radius is going from 0 to 4. But my angle is going from 0 to pi. I'm going from 0 to pi. My radius is going from 0 to 4. Notice again, I'm saying radius, theta, angle. Okay, that's where they're corresponding. So my radius is going 0 to 4, while my angle is 0 to pi of all this stuff. Now, how many r's do I have total? When you distribute this guy, 2, 3, 4 r's total. We got a cosine squared, and then we got a sine, dr d theta. Of course, just like all the others, I want to take the integral of this part first. And so my integral with the r will make it r to the 5th over 5. Cosine squared Tried to make it look good. There we go. Sine from 0 to 4, d theta. 0 is going to cancel. The 4 can get plugged in. 4 to the 5th power is big. 1024 over 5. Integral of, and this is where I'm going to rewrite it just a tiny bit, cosine theta, all squared, sine theta, d theta. Okay. Obviously, I tossed that number out to the front. Why did I rewrite it instead of having cosine squared in that? Because I think it's confusing, when rather I'm seeing this as a u substitution. So du would be negative sine theta, d theta. And you can see right here your plug-in situation here. The only difference is that it's negative. So negative in the front. Integral of u squared du, essentially. Which is super easy, because now you got u cubed over 3. And you already know what u is. Go ahead and make that 15 in the bottom. U is your cosine, so cosine cubed theta from 0 to pi. So plugging in the pi into this, you get a -1. But notice that we already have a negative in the front, so 2 negatives will make a positive in the end here. Minus a negative, but here we're plugging in 0, you get basically, 1. And so then you get to have minus a negative makes another positive of the same thing. So essentially we're doubling it. 2048 over 15. And there we go. Next problem. 153010. So they say double integral over a region 4x minus y dA. And they say that this was going to be the first quadrant. X squared plus y squared is equal to 4. X equals 0. Y equals x. What is that going to look like? Well, y equals x is a 45-degree line. X equals 0 is right here. It's the y-axis. And then this is a circle, radius 2. So that, I mean, that would basically go all the way around. But we're only talking right here in this slice of the pie, I guess you can say, out to a radius of 2. So I want to redo this part in terms of r's and thetas. So 4r cosine theta, r sine theta, r dr d theta. And then what is my limits going to look like? Well, my radius is going from 0 to 2. I think everyone sees that. But my angle is now going to be pi over 4 to pi over 2. If I can write 2 better. Pi over 4 to pi over 2. Okay. I got this problem wrong a couple times because of one small slip up. And I hope not to have that problem here again. So let's do the math and see. It'll be interesting. So I'm going to go ahead and, hold on. Before I start integrating, notice that I can pull out an r here, and then I take this r and also move it out to the front. So now we got an r squared for cosine theta minus sine theta, dr d theta. Now I can integrate that r to make it r cubed over 3. There you go. Doesn't look very good, but you got the idea. Again, cosine, sine. It's supposed to be a 4. Doesn't look very good. Okay. From 0 to 2. And this is still, well, actually that's pi over 4 to pi over 2. Plugging into 2, the 0 is going to go away. 2 cubed is 8. So basically you got 8/3 in the front of this stuff here. Looking at my answer, I don't think your calculator is going to help you here. Even a fancy Casio, I don't think will give you a good answer. So, I mean, it might, but I just doubt it. So let's go and do the integral of this one now. When I'm integrating cosine, it goes to a sine. When I'm integrating negative sine, it goes to a positive cosine. Pi over 4, pi over 2. So when I plug in the pi over 4, and then let's do that part first. Plugging in the pi over 4, I get a 1 out of that, so 4 times 1. This goes to a 0. When I plug the pi over 4 in, it's basically just square root of 2 over 2. There's still a 4 in the front, and then square root 2 over 2. Well, things cancel, and you can make things look pretty. Notice that as far as numbers are concerned, you're going to get a square root 2 that is able to come out. Then you got 4 divided by 2 is a 2 plus a 1/2. So 2 plus a 1/2 on the inside there. Combine it with this stuff. These guys combine. 32 over 3 minus 20 square root 2 over 3. Lots of calculator work. Okay, next one. 15,3010, and to differentiate, this is an XP. Notice the last problem was 010, but this one's 010 XP. I don't know. So we got area of one loop of a rose curve. R equals 6 cosine of 3 theta. Now, I would almost recommend graphing this in your calculator with polar mode on, and that way you can kind of see what it looks like. I had to kind of guess. I didn't actually do that, but I can kind of guess my way around it a little bit. That you're looking for one petal, and I think it's going to be looking like right there. There's a lot of others, but that's kind of what we're looking at. You can also go for another petal right here, let's say. It doesn't really matter. We're just looking for petals. So I'm trying to see when this radius here is equal to 0. The 6 obviously won't matter. So I'm saying, when is this guy here equal to 0? Well, cosine is equal to 0 whenever that inside angle is at pi over 2, 3 pi over 2, etc., etc. You can go negative pi over 2. I did not go this route, but I think it would probably be better in the end, because these right here are actually giving you this petal right here, while these two here would have given you this petal right here at the beginning. But I'm going to keep going this way because that's what my notes have. But I think, honestly, between you and me, I believe that this negative pi over 2 probably would have been a better choice. Divide by 3 on both sides, and so then we get pi over 6. You know what? I'm going to do it. It is better. Okay, so pi over 6, negative pi over 6. Those are my angles. And so, let's go and find it. Notice they're looking for an area, so that's going to be 1 dy dx. But then what does that translate to into polar is 1 r dr d theta. My radius is going from 0 out until this function. I mean, notice they literally gave you r equals. And then I'm going to go from negative pi over 6 to pi over 6. Now, it's symmetric, and so I'm going to teach you a little trick here. You could say 2 times going from 0 to pi over 6, everything else staying the same, just because I know that it's going to be symmetric. R dr d theta. It's going to make it a little easier in the very end. You do not need to do that. But I'm showing you because I think it's a clever little trick that does actually help you out in a lot of cases, okay? So I'm going to keep rolling like this, but you don't have to do that. You can keep going this way. It should be fine. I did it this way on my notes, but I think this will be easier. So we're going to integrate it, so then we get r squared over 2, obviously, from 0 to this stuff here. And you can take that and toss it in. Notice that the 2 comes out to make a 1 in the front. Yeah, just 1. So then I got 6 cosine of 3 theta, all squared, d theta. 0 to pi over 6. Okay. Well, when you distribute your square, you get a 36 in the front, essentially. And then we got this cosine squared of 3 theta d theta. Definitely we're going to be using formulas for this. Cosine squared, you can see it's right there. Just a formula, 1/2 times u and all this stuff. Well, here they're assuming u for u substitution. So du, obviously you would have a 3d theta. You divide to get the 1/3. So 36 over 3 is in the front now. And then you have cosine squared of u du. And that's what we can actually now use that formula for. So 1/2 u and then plus sine cosine. So 1/2 times u plus sine and cosine. Notice that I just plugged the u back in immediately from 0 to pi over 6. So 36 over 3, isn't that 12? So like, we could definitely simplify a little bit of this here. 12, and then divide by half is going to make it a 6, right? So 12 over 2 is 6. And so then I got, plugging this thing in here, here, and here, we got 3 times pi over 6 plus sine of pi over 6 cosine. Oh, hold on. It's 3 times pi over 6 and cosine of 3 times pi over 6. Whew, okay. When you plug in the 0, think about it for just a second. You got 0 here, sine of 0 is 0, so this one will actually cancel out. You don't even need it, which is good. That's why we did that 2 times in the very beginning. This 6 here is still going to have to distribute to both of these here in just a second. Notice the 6s are going to cancel to make it 3 pi. On this side, I got 6, and then notice I got sine of pi over 2, and then I got cosine of the same thing, pi over 2. Well, cosine of pi over 2 is equal to 0. Cosine at 90 is 0. So basically this whole thing goes away, leaving it behind 3 pi. That was much better than the way I did it. Okay. Keep cruising. Lots of good problems coming up. So 15.3.022. They say that they want to be inside of x minus 4 squared plus y squared is equal to 16. And they want to be outside of x squared plus y squared is equal to 16. Now, I know that they both have a 16. I don't know if it's always that way, but I think so. I mean, it surely makes it easier, and I don't think I saw something radically different about this. We definitely need to graph this thing. So notice that this is a circle radius 4. 1, 2, 3, 4. 1, 2, 3, 4. So we're going to make a circle, and we're supposed to be outside of the circle. This one here, it's shifted by 4, and then it's a radius of 4. So it's shifted 4 over, and then 1, 2, 3, 4. It'll look like this. So that's my other circle there. So outside of this circle, but inside of this one means all of this moon shape. See how it kind of looks like a moon? But I don't know if it's officially called a loon. Loon, like for lunar. It's actually an official shape. But I can't remember if this is actually that shape. Because, I mean, you could use parabolas and stuff to make it look similar, you know? Anyways, there you go. It might actually be a loon. I'm going to move on. So we got this area here that we're trying to find. So area, obviously, is 1 dy dx, but in polar, it's r dr d theta. 1 r dr d theta. So what do we put in for my limits? That's going to be the question here. Well, notice that I want to have equations in polar mode for each of these, and you can do it. This one's simple, r equals 4. And this is r squared, square root both sides, there you go. I'm going to give you a hint about this one. Notice that my circle's been extended out by 4, and then it has another 4, so total it has 8. R is actually equal to 8 cosine theta for this one. Now, could you take this and eventually get to that with a lot of math? Yes. That's I'm pretty sure it's kind of a pre-calc thing. I'm not going to go that far. I'm not even going to worry about it. I'm just saying this is that formula because, again, If you've noticed how polars are, this is one of those familiar polar equations. Well, notice r equals this and r equals that, so I could put them together and start solving. So cosine equals a half, which only happens at negative pi over 3 and pi over 3. There you go. So what does that mean for my theta? I'm trying to say that it's these angles here. This right here is negative 60 degrees, and this is 60 degrees, and we're going this way for my integration. As far as how to get this area here, you could do top minus bottom. Notice that, like, if I extended it out, I got my top way out here, and then my bottom would be this guy. So I'm saying the far one minus the short one. So what would that integral actually look like now? Well, r dr d theta. My bottom radius r is going to be a 4, but my top radius is going to be that function there, 8 cosine theta. My angles should be negative pi over 3 to pi over 3. And there we go. Solve. So first off, integrate my r squared over 2 from 4 to 8 cosine theta d theta. Toss this guy in, toss in the 4 as well. I think I messed up on this problem one time by not remembering to put that 4 in there. That's actually vital to the answer, if you want to know. So then what do I get? I get 8 squared of 64 divided by 2 is 32 cosine squared, minus, when I plug in the 4 squared again is 16 divided by 32 now, is an 8, I believe. Hold on. Apparently I skipped ahead. Yeah, it's 8. Sorry. Did I mess up here? I put a 64 here on my notes. But I have a half in the front. Okay, hold on. Let me just make sure I'm doing it right. Sorry. 4 squared, 16 divided by 4 should be an 8, right? And so if I had the 8 squared of 64 but divided by 2 is a 32. Yeah. So I don't know. My paper doesn't look right, but, well, whatever. We're going to figure it out. Maybe I messed up somewhere on the paper. So this right here, if you wanted to do a calculator, I doubt it's going to actually give you something coherent. Notice that we have a cosine squared when I integrate that here in a second. I'm going to have to go back to these formulas. So half u and cosine sine. But thankfully it's just a basic theta, so that's not going to be too bad. 32. And so then I have a half times theta plus sine theta cosine theta, and minus 8 times, well, theta, because I'm integrating. So there you go. From negative pi over 3 to pi over 3. Now, if you go back to the shape, it's symmetric. So if I just took the top half and said times 2, it would make it a lot easier. So I'm going to say 2 times all this stuff, but then from 0 to pi over 3. It's going to make it a little bit easier. So doubling all this, I actually get 64 instead. Actually, hold on. It's kind of funny how this works. Notice the half in the front there? So 2.5. Like I'm basically taking all this and saying times 2. So then the 2.5 cancel, make a plain old 32. Times theta when I distribute it. 32 sine theta cosine theta. That 2 still extends over here, so then minus 2 times that would be a 16 theta. Now these guys are going to combine like terms. 16 theta plus 32 sine theta cosine theta from 0 to pi over 3. Whenever you plug a 0 in, it's all going to cancel, but the pi over 3 is actually going to be meaningful to you. So 16 pi over 3, 32. Sine of pi over 3 is going to be square root 3 over 2, and cosine of pi over 3 is a half. 16 pi over 3 plus, and when you do the math here, that's a 4. canceled with that should make an 8. Let me just double check. Divided by the 4 is an 8. Square root 3. And that is indeed the answer. Yeah, we got it. I did it way different on my notes here. And I'm pretty sure I messed up somewhere along the way, but, well, whatever. I don't care anymore. Let's keep going. Got more problems here for you. 15.3.031. So they want below a plane 6x plus y plus z equals 4. And they want above x squared plus y squared is less than or equal to 1. Again, I'm assuming the xy plane there. So what I'm going to take is move that over to make a z equals. And so therefore, to find the volume, which I'm pretty sure they're looking for, it's going to be 4 minus 6x minus y dy dx. And of course, we can put stuff in and make it work. But I would rather go to polar mode. Notice that my radius here is going to be going from 0 to 1. I mean, this is what's going on, but it's saying less than or equal to 1, so it's going out until radius 1. So here we go, 0 to 1. What's the full circle's angle? 0 to 2 pi of 4 minus 6 r cosine theta, r sine theta, r dr d theta. Okay, when I start integrating for my r in particular, I got 4r. It's going to say r squared over 2, so make a 3r squared essentially. We're just trying to make it simple. And then here we would have a 1/2 r squared sine theta. Whoa. Pause and retract all that. I forgot about my requisite r. Distribute that first, and then you can start integrating. So you got a 4r, r squared over 2. The 2's cancel, so 2r squared. It's a r squared cubed over 3. The 3's cancel, leave a 2, r cubed. I'm distributing it, and then I'm integrating. I'm still actually integrating here, okay? R squared, r cubed over 3. Nothing to cancel there. From 0 to 1, d theta. The 0 will cancel. The 1 makes everything easy, so that's good. So here we got a 2 minus 2 cosine theta minus 1/3 sine theta d theta. At this point, you could consider using a calculator. Again, I doubt it's always going to work for you, so I don't want to assume that, but I mean, it is a possibility. Once you ever get it down to a single integral, I'm basically, you can wipe your hands of it and go right to a calculator. You can say, oh, well, I've seen that in Cal 1 or 2 before, no big deal. This is not as bad. Our task in Cal 3 is to make a double integral down to a single integral. From here on, it's just kind of stuff that we've seen before, but it's still good stuff. So integrating, I got a 2 theta here. Cosine is going to go to a negative sine, and then this negative sine actually goes to a positive cosine, I believe. Oop. Still got a 1/3 in the front. From 0 to 2 pi. So when you start plugging this stuff in, it's pretty interesting. 2 pi there, you got a 4 pi in the end. That is going to zero itself out. And when you go 2 pi times this, that'll be a 1. So you got a 1/3 there. Minus, when you plug in a 0, you get a 0. Plug in a 0, you get a 0. Plug in a 0, you get the 1/3 again. But notice that it's minus 1/3 there. So these guys cancel actually, leaving you behind with just a simple 4 pi. Okay. I still got a few more questions, so let's keep going. 15.3.032. They want inside of the sphere x squared plus y squared plus z squared is equal to 25. They want outside of the cylinder x squared plus y squared equals 1. This one is just a strange problem, but I love it. It's a great problem. Let me show you what's going on. We got a sphere, right? And then they have a cylinder that goes through it. Sorry, I'm kind of messed up my colors there. I got a cylinder that's going to be, ooh, that was not well done. A cylinder that's going right through it. So then when it's cutting through, it's about right here. And if you can notice, I'm cutting out the cylinder from a sphere. Outside of the cylinder, but still inside the sphere. What you're making is a bead. A bead. Like, it goes around necklaces and stuff like that. You have you got a sphere, and then you drilled out a hole in the middle of it, okay? So you're talking about a bead. Okay. So how do we find the volume of that bead? What I'm going to tell you is probably how a lot of them are manufactured. Notice that I put it this halfway mark here. I'm going to think of it kind of like a dome, and then I'm going to cut the dome out, and I'm going to say times 2. Okay, it's going to be a little easier just to do the top half, and then you start doing the math for that one alone. If you're wanting to know what it looks like x, y, y's, is notice that we have a radius of 5, and we have a radius of 1. And so radius of 5, radius of 1. So this is what it would look like from the top down. Okay, so that's my region that we're going to put into my integral. So here we go. Double integral of z dy dx. Because again, we're trying to find volume, right? And let's go ahead and put a 2 in there. But what is z going to equal in this particular case? The only way to get it is if I move this stuff over in square root. And so essentially here I got the square root 25 minus x squared minus y squared dy dx. Again, I don't want dy dx. I'm wanting dr d theta. So I'm going to mix it up. I don't recommend doing this, but basically you can see that I have a dr d theta instead. Well, that's incompatible with these x's and y's. So we actually have to go and redo this one here. Notice that you can pull out a minus sign here and make it negative x squared plus y squared, basically, which is r squared. And then r dr d theta. So now that's compatible. As far as radius and stuff is concerned, again, we're talking about a two-dimensional region. We're going from 1 until 5. 1 until 5. And we're going a full circle. Now, you might have thought, oh, we're only doing half of it, the top dome. Yes, but notice, like, if I would have done the bottom half here, I would have had to say it would be plus or minus the square root of blah, 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 right? Positive and negative. Well, I'm only using positive here, if you noticed, right? I'm only using the positive version. So that's already the top half, but we have to still go full circle for that top half of the bead. Okay, now that we clarified. Use substitution on the inside here. That's supposed to be a square. du, sorry for the sloppiness, du, negative 2, r dr, divide, 2 is going to cancel, make a negative in the front, etc. So then you basically got square root of u, du, d theta. There you go. Again, you got to make sure that you haven't actually integrated yet. And the 2's cancel, by the way. Just let you know, that r right here is that r right here, and those canceled as well. Just kind of making it a little bit quicker for you. So that's 1/2. You add 1 to the power and divide by that new power from, oh, actually I don't know yet because it's still use. Go back and rewrite it, not use, but of course r's and stuff. Actually, you know what's kind of funny? This 3/2 is basically a 2/3 in the front. So I'm just going to go ahead and do that. Makes it a little bit better. From now, 1 to 5, d theta. So plugging in a 5 is kind of interesting. What do you get? 25 minus 5 squared is going to be 25. So 25 minus 25 makes a 0. Essentially got 0 minus integral of whatever. But notice it already had a negative. 2 negatives are going to make a positive in the end. So, in fact, what's happening is that the 1 is going to be the only relevant number, and it's going to change that negative into a positive. So, like, 1. Oh, it's relevant, but it doesn't equal 1. it's now 25 minus 1 squared. That's going to be, what, 24? So actually it's weird. It's like 24 to the 3 halves, and then times the integral of 1 d theta 0 to pi. So I just took this as a number and put it in the front. Integrating 1, you get a theta. You put that 2 pi into it. It's got 2 pi. And that's basically your answer here. You can definitely clean it up a little bit. They cleaned it up to make it a 64 square root of 6 pi. I would not have gone that far, but that's their answer. I'm sure that WebAssign would take something before that. Okay, 2 more problems. They're actually a little easier. Well, they're a little smaller, at least. So they got double integral 0 to 6, 0 to the square root of 36 minus x squared of e to the negative x squared minus y squared dy dx. Now, like, hold up. This is crazy. You can't do this alone. You have to go and take this region stuff and draw it, and then see what you can do for polar stuff. So notice that it's dy dx. My y values are going from this to that. This is actually a half circle. So they're saying 0 to up here, radius of 6, basically. And then x is only going from 0 to 6. So they're saying only this zone right here. So that's my region that I should be focused on. When I rewrite it in polar mode, my radius is going to go from 0 to 6, and my angle is 0 to pi over 2, 90 degrees. See, I'm only going 90 degrees out until 6. And so I need to replace all this here. Notice that if you take the minus signs out, you'll get x squared plus y squared, so negative r squared. R, remember that requisite r dr d theta. Now, that requisite r is very important, otherwise you can't do this integration here. But basically, you're doing a u substitution, du, negative 2r dr, and then you divide by it, negative 2 in the front, and all that stuff. So negative 1/2 from 0 to pi over 2 of the integral e to the u du, and then d theta. Again, we're just going to be doing that one here in a second. What's your integral of e to the u? Well, it's e to the u, and u is a negative r squared from 0 to 6. So plugging in a 6, obviously you're going to be getting e to the negative 36 power. Plugging in a 0, e to the 0 is actually a 1. So kind of funny how that worked there. 0 to pi over 2. I ask you, how many thetas do you see? None of them. So you put a theta in here, toss in your pi over 2. It's a trick that you can see is if you don't have any thetas, you can just multiply by that number if you're going from 0. Just little quick tricks that you learn along the way. So pi over 2. The 2's are going to combine to make a 4. And what they do is they take the negative and distribute it, and then they flip that one over. So they end up with pi over 4, 1 minus 1 over e to the 36, which is totally fine. I don't think you really need to go that far. Last question, 042. So 0 to 2, 0 to the square root of 2x minus x squared, 6 square root of x squared plus y squared dy dx. Okay, what is this region shape right here? Well, if you want to know this shape right here, actually, if you do all the math and replace your r's and x's and y's and sines and all that kind of stuff, because this is technically y equals this stuff, right? When you go through and do it, you end up eventually with r equals 2 cosine of theta. That's like a quicker way to see it. If you've seen this pattern before, you can just jump to it, I suppose. And that's why it explains the 0 to 2, because it's basically a circle that goes out until 2, but again, 0 for my y cuts it off, and they're only wanting the top half of that, okay? All right, so now, that we have that. Let me rewrite it now in terms of r and theta. Notice again, my r is going to go out until this value, so from 0 to to that function. And then my theta is kind of weird because out here is actually 0 angle. Coming back to 0 is pi over 2. So we're going from 0 to 90 degrees, pi over 2. On the inside, so that's a 6r, right? That's r. But then your requisite r still, dr d theta. You got to remember that other r. That makes it an r squared, essentially. So double integral of 6r squared, dr d theta. When you integrate that, you should get 6r cubed over 3 from 0 to the 2 cosine theta d theta. Well, the 3 into 2, 6 into 3 will make a 2 in the front. And then you got 2 cosine theta all cubed d theta, the 0 goes away, from 0 to pi over 2 now. When you distribute your 2, you actually get an 8. 8 times 2 is a 16 in the front. Same angles. Cosine cubed theta d theta. Now, pause for a second. This is not too bad of a, integral, right? Well, cosine cubed, you could probably do some trig identities. This is all back in Cal2. What do? Well, you can also go to your formulas and go through all that stuff. I don't even know. I wouldn't trust all that. You know what I did? I did the calculator. And I got I got an easy number in the end, so I recommend it on that one because it just takes so long. Okay, we're done. That's it. Thank you very much, guys. Have a great day.